Thank you, and I'm Jingtao. I'm from Tsinghua University. Today I'm going to present my paper, and the other authors are Qingyao, Yiqun, Zhan, and Shaoping. This is a joint work by Tsinghua University and Xiaohongshu. First, let me present the background about text-to-image generation. Text-to-image systems have revolutionized the field of art creation. You can see that you can generate an image very easily by just presenting the text prompt. So you can see that the challenge to art creation already shifts from drawing techniques to how well you can write a very good prompts. But can users really write very good prompts? And the answer is that many cannot. Because if you want to write a very good prompts, you need to have a lot of knowledge about art, like some artists' names, styles. And you also have to understand how to express your needs in the prompt, like about the details of the background, the look, and the body. And you need to have a lot of experience about the specific system because you know that different systems have different needs for the input prompt styles. So we believe that to address this problem, we need to train an automatic prompt reformulation model. The input of the model is a user-written prompt, and it should output a high-quality prompt that we can use this prompt for generation. The benefit is that you do not need the users to be familiar with the system and to know how to write good prompts because the model can automatically do it for the users. In fact, many existing text-to-image generation systems have already adopted such reformulation model, such as Dolly from OpenAI. The challenging part for such kind of automatic reformulation model is that it's very difficult to train. Traditionally, reformulation models are usually trained with input-output pairs such as machine translation, query reformulation. But for prompt reformulation, it's very difficult because you know that even for us, the developers, we do not understand how to write a very good prompt. And we cannot expect to recruit some code source workers to do this labeling work for us. And therefore, it is very hard for us to train it. In this paper, we want to use the user log as the training data. That is, when a user interacts with the system, you can see that many people want to draw something, but at first, the very first prompt is not very good. And then they will keep reformulating the prompts and until then they have a very good results. So we believe that maybe we can use the first prompt of a session as the input and use the last prompt of the same session as the label. Actually, this is also used when they train the query formulation models for the search engines. We use this strategy to train our first version of a model, but sadly it does not work. Why? We do a lot of work to try to analyze it, and we finally found that the reason is that users actually cannot improve prompts very much in just one session. If we compare the generation system with the traditional search engines, we will find that the generation system is very much more complex. People actually do not understand how prompts influence the generation process, and moreover, the generation results, such as the images, do not help the users to reformulate the prompts. It does not tell the users what artist names they should include in their prompts. On the right side of the slide, you will see a figure. This is our analysis results for a real user interaction log. The x-axis is the generation quality of the first prompt of a session, and the y-axis is the generation quality after users rewrite their prompts. You can see that if the user cannot write a very good prompt at first, the results after they reformulate the prompt, the generation quality is not very optimal. And you can see that the variance of the improvement is very huge. Therefore, generally speaking, the interaction log is very noisy and to learn from the feedback is very hard. In this paper, we try to address this problem by proposing a new framework called capability-aware prompt reformulation. I believe that the noise from the interaction log is actually caused by the different levels of user capabilities. It means that different users have different skills about how to write good prompts and how to reformulate the prompts, and this causes the interaction log to be very noisy. Therefore, we believe that when we extract the prompt reformulation pairs from the user's interaction log, it's actually not a one-to-one correspondence. Therefore, we break this reformulation process with another latent called user capability. So the first term is that given a user's capability and the first prompt, we need to mimic the user's reformulation process and predict what the user reformulation result is. And the second term is the user's capability. Here is our model architecture. The reformulation model is a large language model, and we will train this model later on. And the input, it has two inputs. The first is the initial prompt, and the other is a user's capability feature. And the model will output the reformulated result. As for what is the user's capability, it is a long context, and it tells us the original prompt leads to an image with quality of blah blah blah, like relevant scores, aesthetic styles, etc. And we also tell the models that users reformulate the prompt, and the revised prompt leads to images with quality of blah blah blah. And we have two training stages. In the first training stage, we train the large language model. We enable it to, based on the capability feature, to reformulate the prompt, so that the input is the initial prompt P, and we compute the capability feature based on the input and the label prompt. We use language modeling laws to retrain the large language model. And we also have a configuration stage. That is, now we have a large language model that can mimic a specific user with a specific user capability to reformulate the prompt. And now we want the large language model to act like an expert to rewrite the prompt for us. So we have a configuration stage that we will specify the user's capability and let it to act like an expert. So we will tune this user capability feature and use some optimization strategies. Now let me present the experimental results. We use a training dataset. It is a public dataset called DifferentDB. It has 1.8 million interactions from 10,000 users. When we evaluate the model, we present the model with user-written prompts and let it to reformulate the prompt for us. And we will input the reformulated results into a text-to-image generation system and then evaluate the generation results. We use two scoring models to evaluate the results, and we apply our prompt reformulation framework to two generation systems. The one is Stable Diffusion 1.4, and the other is Stable Diffusion XL. And here is the first table. It is a result on Stable Diffusion 1.4. This model is also used for users to engage with, so we call it the scene system. You can see that we compare it with some general models like GPT-4, and we also compare it to many state-of-the-art prompt reformulation models. And our model can significantly outperform these models, and you can see that it is because that capability-aware framework can help the models to learn from users' feedback, and learning from user wisdom is really helpful. We also apply our models on another Stable Diffusion XL framework, generation model. This model is not used when the users is engaged with, and so this is an unseen system. However, on this is also a state-of-the-art model, but even it is very powerful, and but our reformulation results also help with the generation results and can improve the generation quality, and it can also outperform other baselines such as GPT-4 and state-of-the-art prompt reformulation models. And now I will present a slide about how capability features enable the model to perform very well. So we evaluate users' capability in 4 perspectives, and they are like user satisfaction, similarity, and maybe we'll first look at the first figure. On the x-axis is how much we instruct the models to improve the prompts, and the line shows how well the models actually perform. So you can see that the model will perform better and better if we instruct the model to improve more and more. So the model can really follow our instructions to improve the prompts. And the interesting part is about the bar. The bar shows the distribution of the training data. So you can see that here there is really little training data available in the log, but because we provide a capability-aware framework so that the models can actually extrapolate here and further improve the performance. And this is part of the reason why our models can perform very well. And now I'll present some cases. You can see that, for example, in the first case, the user wants to draw a picture about a monkey acting as a DG. And if you do not use our capability-aware framework and simply learns from the reformulation behavior in the log, the model will simply rephrase it as a monkey DG. This is because in the framework, the improvement is very little and the model will simply learn it as a rephrasing task. But with our framework, the models can learn to improve it to a large extent. It will add many details such as the monkeys wearing headphones, and it will also add some artist names. And now let me conclude my presentation. We present why it's very difficult to learn from users' feedback. It's because that the user has very different capabilities and it's very noisy. And to address this problem, we propose a prompt reformulation framework. We use a capability-aware prompt reformulation so that it can effectively learn from the user's wisdom and benefit the beginners of the text-to-image generation system, help them to get more high-quality results. Thank you. Thank you.